Hello, we should be live now. My focus today is on Pico-8. We use Pico-8 to make games. It's actually free. At least to use it, to publish, I think you need to buy Pico-8. You have yourself an editor. Here you create your sprites. Here you make a tile map. Here you make your sounds. And here you combine those sounds into music with channels. And at any moment you can press play. And here I have a house. This is the player. And here zombies spawn. And I can place plants. These are my plants. And every like few seconds they grow. And I just had an idea for a game, and for the longest time I just procrastinated on the idea. But once I found Pico-8, I was just like, okay, let's make it into a reality. Um, what will I had an idea with a game like Plants vs Zombies, where you have a garden and zombies come and the garden protects your house. And I was like, okay, what are the plants? And I just started drawing, and this is just one plant. Like, it went really fast, really easy. And then this is the player, and I was like, okay, what will I do for the zombies? Zombies will be just the player, but green, and done. And this is the house. Like, very quick and easy. And for the drawing, it's also really simple. Look at here how you have this number 5. So in the code, I just had to call this function like SPR. I assume it's sprite. The number 5, this number 5. So it's like I'm drawing this sprite. And this is the coordinates. Like the screen is from 00 to 128. It's 128 by 128. So 63 on the X and 63 on the Y is like in the middle of the screen. So draw the 5th sprite in the middle of the screen. It's this sprite. And this is my player. This is my zombies. And this is my plants. And in this stream, I would like to actually use Pico-8 to continue the idea, because I stopped working on this game because I decided there are too many limitations, and I moved to Raylib. And I have the same game in Raylib. I have the same game in Raylib. I don't have the house in the middle, but I have the zombies moving. It's the absolutely same game, because here I have C++, I have a lot more to use. So I removed some of the limitations, but then I stopped working on it. So that's why I'll go back to Pico-8, since here I actually make some kind of progress. All of this is just to make a prototype for your game. To make a prototype just to see if the idea is worth investing more time into it. If you cannot make the idea fun in Pico-8, it will be hard to make it fun if you remove the limitations. So this is my house. I plant zombies, and I plant I plant plants, and zombies come. So now I would like the zombie to come towards the plants. In Raylib, how did I do it? In Raylib, I went through all the zombies. I had the target is the middle of the screen. So I calculated the direction, target minus the position of the zombie. Then I normalized the direction and changed the zombie position. But here I have vectors in C++. And here in Pico-8, I'm not sure if I have vectors. Another cool thing is Pico-8 games run in the browser, and this is a Pico-8 game. Here it's showing like vectors. And here this guy has made written code demonstrating vectors. And here you can actually look at the code. You can look at the code for how he has implemented things. So there's even like Celeste, like Pico-8 Celeste. This is the power of Pico-8, like even Celeste is made with it. It's still too loud. Even a game like Celeste is made with Pico-8. I think they made it in a game jam for like Pico-8 games. And I assume that's how Celeste came to be, in a game jam. And even this game, you can go here and look at the code. You can look at the code they've used. For all the Pico-8 games, you can look at the code and like get inspired. So how is this guy using vectors? Okay, he is using functions. This function just returns this structure. Default values are zeros. Okay, I assume I can just copy all of these. And this is small demo. Okay, so this is all that we need. And now we have vectors. Now we have vectors. Here I can create a new tab. I can paste all of this. And now we have vectors. The issue is this takes up space, and we have a limit like 65,000 characters. And this took and this increased our characters, but it's worth it since so now we can work with vectors. So the zombies, I want the zombies to go towards the house. Here I have zombies in this structure, and every 5 seconds I add a zombie to the left and in the middle of the Y. Next, watch, how should I approach this? Yeah, I should go through all the zombies in the update. Let's copy it. In the update function, I'll go through all the zombies. So this is their position. Now the target is 63. We need direction, which is zombie. What was it? Do we have subtraction? V sub equals V sub zombie minus target, and then dir equals v normalize, norm, right? Norm dir, and then zombie equals v at zombie and dir. And let's see if this worked. Function v at attempt to perform arithmetic on field x a nil value. Ax. Oh, okay. Yeah, I get it. At least it's using these functions. That's very good. When we add here, when we add zombies, we will add as a vector. As a vector. And here when we draw them, we will do x and here y. And now we wait. Here's the zombie. It's not moving. What's the issue? The update function. Where did we? Yeah, here. We go through all the zombies. The target is in the middle of the screen. I subtract the zombie position from the target to get the direction. I normalize it. Then I add to the zombie position the direction. And here I go through all of them and draw them. The direction is not oh, let's look at how the functions work. Viat, it returns a new vector that combines the values. So here I say the target. Oh, I see. So here we are saying the zombie position equals to the result. But I think we need to do like this result and then like zombie x equals result x, zombie y equals result y. I think this is what we need. Yeah, but it's going in the other direction, so these we have to switch these two. And now it should work. Yeah, now it's going towards the house. What next? Next, now in this game, the quick demo, we need the something to happen when they reach here, like a game over. Maybe the house to have health. And I want to see if um, to have the player go inside the house to sleep, and that's when zombies come. So is sleeping is false, and I'm wondering if we need to implement that, like the sleeping part, as of now, as a priority. Maybe priority is like zombies attacking the house. There is a Pico-8 cheat sheet of what we can use. I'm looking for collision. Comments, tables, add a value, flow control, operators, shortcuts, color palettes, screen. Okay, camera. This probably changes where we're looking at. Clear screen, color, pget, pset. That's probably pixel. Flip, clip, shapes. This is to draw something. Sprites. Pico-8 collision. Okay, here is some basic collision. And how does he do it? Let's look at his code. Oh, he has here something. No, look, let's look at the code. Init, collide with map tiles, collide with world bounds, move player, see map, move. Here we're moving an object. So we're getting his last X and Y. And we are updating the new X and Y based on the button presses. And if CMap O, we don't move him. So we only move him when there's no collision. So what's CMap? It's his function. This is for the world bounce. This is for colliding with map tiles. If then I assume this is just true. X1, Y1. A, B, C, D. CT, false. Oh, it's this is a boolean, and the boolean is so if there is a collision if A or B or C or D. So we are getting the just points. Like this is 1 point, which is probably top left, and this is another point, which is bottom right. So the minimum X, maximum X, minimum Y, maximum Y. So this is box, aligned, collision, something like that maybe. So A is F get, M get. What's M get and F get? Pico-8, M get. Pico-8, F get. Guess the sprite number assigned to a cell on the map. Guess the value of a flag of a sprite. So we start with a name get. Guess the sprite number. And then F get. Guess the flag of a sprite. Yeah, I remember the flags. It's these things here. Flags. Set flag for the sprite. So basically it's looking at the corners of the sprite, like, and like the neighbors. It looks at the neighbors, and if it's like, let's say this sprite, it looks at its flag here if it's set. So we can say like we want to collide with the house. Okay, so now I can go inside the code and I can make a function like that. Function move but this is this takes up input. Instead, I'll have the player here, like the object. I'll have here the object and the direction. So he does this. This is the previous X and Y. And we need the new ones. So I'll do no, it should be like last position will be object position, and then object position equals v at object position with direction, with the direction, and then we do if collision object if Then and if there's collision in the new position, we do object position equals last position equals last position. And now we need to implement collision, which is this function. So we do function collision object, and here I don't need this. It should be end, and here it should be end because it's Lua. So for the collision, it's only this part. And here it's return, I think. Where's the collision? Yeah, return. But here it's object. I can just call it O, like he does. And it should be dot position. Like that. And where do I move the player? Here. I'll do move dir equals vector with zeros, and then here move dir x, then move dir x. I'll just copy it, paste it, and here I'll have player equals this table. To equal this table, and player position to be vector 63. And then when we draw him, where is the draw function? Here. Player position x, player position y, and I need here in the update move player, move direction, and at least it's moving, but there is no collision. Why is that? Do I need here to add as well the flag? Let's bound the player here -8. Yeah, to be above. But there's no collision. How to approach that? So we're saying to move. If object is colliding, then we don't move him. So here, all the time, this is giving me like false. There's no collision. Here we're getting the sprite, then the flag, if and the flag is boolean, if true or false. And it's always, so all of these are always false. I've seen some questions about how to do collision detection. Bare bones demo. World bounce. Oh, it's using map tiles, I think. 24 lines. It includes flags for turning collisions on or off on an object. If colliding with map tiles, but this is map tiles. Colliding world bounce. It will return true if collision is detected. You need to do following global variables. Um, I can. I could mget fget mget pico gets the sprite number assigned to a cell on the map, but we're not using the map. We're not using the map. I'm directly drawing the house. We can use it if I, like, this is the, like, I can do map. And here in the tile map, I'll just put the house. And yeah, now we collide. The issue is it's not in the middle of the screen. Sget. Oh, I can do sget. Fget. Sget Pico-8. Get the color value of a pixel on the sprite sheet. It's not that. Of a sprite. Um, Sprites, sprite, sprite, sget, fget, map, mget, mset. Um, mset Pico-8 sets a cell on the map to a new sprite number, cell X, cell Y. Yeah, we can do this. Let's, instead of drawing the house, I can do in the init m set it's 128 by 8 16, so 8, the cell 8 that's on the cell X and cell Y, it's 8, and the sprite number is a 5, and we draw them up. Yeah, we have the house and we're colliding with it. And now I'll have the same code for the zombies. So when I add the zombies, I'll add them not as a vector, but pos equals, like that. And when I draw the zombies, here, zombie, position, position, and I need to move them. Move zombie direction. And now there should be collision between the zombies and the house. Attempt to perform arithmetic on field X a null value. Where is that? Line 23. Zombie equals zombie position equals like this. And here at zombie. And now let's see. Attempt to perform attempt to in v subtract. Okay, line 47 actually. Line 47. Here. Oh yeah, I see. So zombie, here it's zombie position. Yeah. And now, yeah, now we have the zombie and it's colliding with the house. And the plants are spawning at the top left for some reason when we draw them. Let's do plants. What's the issue? When I press Z. Yeah, here we want... Oh, yeah. Because I was taking the player X and Y and we changed the player. Player position X, player position Y. And now we can spawn the plants. Now it would be cool if the plants attack zombies. in the update, we could have each plant can have a field that's like hmm. So the plant has stages, and when it's at the last stage, I want the plant to start attacking zombies around it. Let's actually, when we create the plant, here we can like do plant. Here we create a plant. Plant position equals player position. And plant stage equals 1. And here we do plant. And when we draw them, we go through the plants. We do plant position X, plant position Y, and here plant stage is the same result. Oh yeah, when we update it. When we update it, here it's stage, stage. Yeah, now it's working. Now, here we create the plant. I'm thinking of having the plant to remember the last time it has shot, because it will shoot every second. Should it be different for every plant? Yeah, it will look better. So plant last update, it will be time. And we go through we'll go through all plants. We go through all the plants. We get the current time, and we compare if plant stage is equals 3 and where is the cheat sheet? And so it should be and equals. Okay, if stage equals 3, so it has grown the most, and plant what's it called, last update plus 1 is less than now, then and plant last update equals now, and Here we should do the shooting. Shoot. Here we should do the shooting. Function shoot plant. And let's create a shot. What is the sprite editor? It will be like we need a circle. Like this. Let's see. We shots. We'll have a table of shots. So this shoot function, we don't need it. We need a target. We need a target. Target of a zombie. So we can go through all the zombies and just pick one, or like to pick the closest zombie. Closest zombie. And then to go through all the zombies. Difference equals a vector subtract plant position, zombie position, and then we need to get the length, the magnitude, but there's another way. Distance squared. Distance. Because the magnitude uses square root, but we don't need the exact distance between them. We need to compare distances, and for comparisons we don't need square root. This is v dot. This is mag square distance Okay, we can use this dist square. Closest distance. And let's like pick a big number. And here current distance is current distance is plant and zombie. If current distance is smaller than closest or like smallest distance, then we want the closest zombie to be equal to our zombie. Now, after we go through all of the zombies, we want how to check if this we haven't found a zombie to shoot. Tables. How to check if a table is empty. Pico-8, check table if empty. Okay, we can do it like um, if they are zombies, like if they're in like the length of the, but can we do length of a table? All pairs. Pico-8 length of table. Let's do a test here. Like if zombies equals null, 0, and can we like print somewhere? Yeah, okay, let's spawn the house if there are no zombies. Then, okay, if it's 1, okay, and here let's add zombies, like 2 values. It's having problems from other parts of the code, but I think this should work. This should work. Now we now here, if zombies if they are zombies. If they are zombies, we create a shots. We add to the shots a shot which has a position, plant position, and it should have a target closest zombie. The issue is that this target, like, does it make a copy? Like, because the zombie will change position and the bullet needs the position of the target. Yeah, we'll call it a day. We did enough. We can do save. Yeah.